Hello, the objective of this video is to learn how to use exponents to write large or small numbers and vice versa, and to solve problems. Now, for this you need some vocabulary. Power. Power is a product of repeated factors expressed using an exponent and a base. For example, you have x to the fourth power. X to that fourth power there. The base is the common factor in a power. In the example x to the fourth, x is the base. The exponent is the number of times a base is used as a factor. In the example x to the fourth, 4 is the exponent, and that would be x times x times x times x. X times itself 4 times. Monomial. A monomial is a number, a variable, or a product of a number and one or more variables. In this case here, I've got 3x squared in that example. X being a variable, 3 being the number in front, they're being multiplied, so it forms a monomial. No addition or subtraction involved there, just multiplication. Polynomial is an algebraic expression that contains more than one monomial. Example, 3x squared plus 2x. Notice how we have an addition in here, in the middle here. Once you start adding or subtracting monomial expressions together, you get polynomials. Squared. You'll hear me talking through the video where I mentioned squared and cubed. Squared is a power with an exponent of 2. It's raised to the second power. Cubed is a power with an exponent of 3, or raised to the third power. Here we're asked to write an expression using exponents. Looking at this one here, to write it with exponents, we count how many times the 5 is being multiplied there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is equal to 5 to the 9th power. That's how I write it using exponents. This is negative 2 times negative 2 times negative 2 times negative 2. How many negative 2's are there? There's 4 of them. They are all being multiplied. To write that with exponents, you would write negative 2 in parentheses to the 4th power, with a little 4 up there. Basically, if you have any number being multiplied repeated times like this, you would count up the number of times. 1, 2, 3, 4, 5, 6. I have 6 x's being multiplied here. So that gives me x to the 6th power. That's how to write the expression using exponents. Let's try a couple others here. Now here, this is a little more complicated. It's not just one set of numbers, it's 2 different bases. When you're counting these out to put the exponent on here, you can only count up the ones that have a like base, which means these 2's are the same here. 1, 2, 3, 4, 5. I have 5 2's. That's 2 to the 5th power. I have 1, 2, 3. 3 3's. So I have 3 to the 3rd power. And those still get multiplied because that's the operation here. So I have 2 to the 5th times 3 to the 3rd. I cannot make this 2 to the 8th or something else like that. I've got to keep this with the like bases having their exponent. It does not suddenly add these exponents up. This part becomes the 2 to the 5th. This part becomes the 3 to the 3rd, or 3 cubed. Here I've got 3 x's. Remember, in algebra we don't have fruit salad, so I can't combine these. I can't count the x's and the y's together. X, 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 that's x to the 3rd. Y, 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 y is 4 y's, so we do y to the 4th. How many z's are there? There's 1, so I do z to the 1. Do I actually have to show the 1? Well, we'll get to that a little bit later. But these are all being multiplied. I could put the dots there for them, or I could leave them out, because whenever you have 2 variables next to each other, you know you are multiplying. Here we got negative 1. Well, there's only one of those, so let's put that there. Times 2 times 2 times 2, that's 2 to the 3rd. So it's times 2 to the 3rd power. And x times x is x squared. Now, when you multiply by -1, you know everything here is going to stay the same. It's just going to become negative. So you'd actually write this as -2 to the third x squared. This is different from the -2 in parentheses to the third power. We're going to see that in a later screen here. Okay, I want you to take a moment and do these problems. 3 problems here. Pause the video, give them a try. Welcome back. A times A is A squared. B is 4B, so it's B to the fourth. This one, 4, -3, so it's -3 in parentheses to the fourth power times x squared. 2 x's, x squared. Now the fractions here, you may have been confused by this because they are fractions. Well, you could just as easily put these things in parentheses like this, which means you have 3/4 being multiplied by itself 1, 2, 3, 4, 5 times. So you have 3/4 in parentheses to the fifth power. When you add the exponent, you have to have these parentheses because this is not the same as 3 to the fifth power over 4. Not the same thing. They are not equal. You've got to have the set of parentheses there. When you're working with fractions like this to the exponent, we'll get to it at a later time where you're going to see how you can distribute that exponent. But again, for now, all we're looking to do is to express it using exponents, and that's your answer. Evaluating powers. When you're asked to evaluate an expression like this, they're asking you to simplify into actual numbers. 2 cubed is 2 times 2 times 2, which is equal to 2, 4, 6. Sorry, not 6. 2 times 2 is 4 times 2 is 8. It's not 6. That's a lot of people make that confusing. 2 times 3 gives you 6, but 2 squared, 2 to the cubed is 2 times 2 times 2, which is 8. And we still need to multiply that by the 3 squared, which is 8 times 3 times 3. 3 times 3 is 9. 9 times 8 gives you 72. That's your final answer, 72. Here we have 1 to the 8th. Well, 1 to the 8th is 1 times 1 times 1 times 1 times 1. It's 5, 6, 7, 8. But 1 times anything is itself, and 1 times 1 is going to give you 1. So it doesn't matter whether I have 1 to the 8th or 1 to the billionth, it's going to equal 1. So all that becomes just 1. So we have 1 times 2 squared, which is 2 times 2, times 3, which is just by itself there. 1 times 2 is 2, times 2 is 4, times 3 gives me 12. There's my final answer on that one. Now this one I broke up, I wrote in two different problems here, and they are 2 different problems. -2 in parentheses to the fourth is the same as saying -1 times 2 in parentheses to the fourth. Whereas -2 to the fourth like this is the same as saying -1 times 2 to the fourth. Big difference here, because remember with the order of operations, grouping symbols come before exponents. Parentheses before exponents. When you write like this, you've got to do the times first before you do the exponent here. So you'd have, this one works out to be -2 in parentheses times itself 4 times, which is going to give you negative times negative is a positive, so that's positive 4. -2 times positive 4 gives you -8. -8 times -2 gives you a positive 16. Whereas over here, it's going to be a little different. This is going to be -1 times 2 times 2 times 2 times 2. Oops. And 2 times 2 times 2 times 2, we know it's going to work out to be 8. This is going to give us -8. Whereas this, sorry, not 8, It's going to work out to be 16. It's going to work out to be negative 16, whereas this came out to be positive 16. Two completely different values. Yes, they're both 16, but negative 16 is completely different from positive 16. So you got to be careful. When the parentheses are around here, it's included with the exponent. When there's no parentheses around the negative symbol there, you've got to take it out separately, and whatever the number works out to be simplified, it is negative. Powers of 1. If you have anything to the power of 1, it's the same thing. 3 times itself, you write that as times 3, because you're multiplying by 3 once. What are you multiplying by 3? Well, you're going to multiply 1 by 3, because there's actually understood to be a 1 in front of there all the time. Just like there's understood a 1 times in front of it all the time. 1 times 3 is going to give you 3. Remember how when we have x by itself, it's understood to be the same as 1 times x? So this becomes 1 times the x itself once, which is going to give you just plain x. Basically, what it boils down to is anything to the 1 power is equal to itself. It doesn't change. Anything to the first power is going to equal to itself. 1 billion to the 1th power, to the first power, 1 power is going to be 1 billion. Evaluating 4. Now remember, when you evaluate 4 things, you've got to be able to plug and chug. Evaluate these expressions for a equals 5 and b equals 2. To do that, I would first plug in the values. So this becomes 5 squared plus 2 squared. 5 squared is 5 times 5, which is 25. 2 squared is 2 times 2, which is 4. Add those together and you get 29 for your final answer. Here, when we plug it in, we're going to have 5 minus 2 inside of parentheses and then squared. Remember, when parentheses come before exponents in the order of operations, so we've got to do the subtraction here first. 5 minus 2 is going to give me 3. 3 squared is 3 times 3, which is 9. Over here, we're going to evaluate for x equals 3 and y equals negative 2. So for that, first thing you do is you got to plug it in. Negative 2 times 3 cubed. 3 cubed, exponents get done first. 3 to the 3rd power is 3 times 3 times 3. 3 times 3 is 9. Times 3 again, you get 27. So at that point, you have negative 2 times 27. Then you got to do the multiplying here. Negative 2 times 27 gives you negative 54. And that's your final answer on that one. For over here, we plug the values in. We get 3 squared. It might help to put these in parentheses just to keep things, you know that you plugged in the 3 there. And then we have negative 2 to the 3rd power, which is going to be equal to 3 times 3 times the negative 2, negative 2, negative 2, negative 2 cubed. Remember, you've got to do the exponent parts first, so you have to do this 3 times 3 first to get the 9. Multiply these together. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8. 9 times negative 8 gives me negative 72 for my final answer there. You do. Now here's 4 problems that involve evaluating 4 of these values. You're given the values of x equals 2 and y equals 5. Plug them in. Pause the video, try these 4, and we'll check out the answer when you come back. Welcome back. Now this one, there was nothing to plug in. You just had to evaluate. So 2 to the 6 would be 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 2 times 2 is 4. Times 2 is 8, which so far we've got that. That makes this 16. Times 2 gives me 32. Times 2 again, I get 64. So my final answer on that is 64. I could also do every 2 times 2 is 4. 4 times 4 is 16. 16 times 4 will give me the 64. So I can look at it that way to help me get the answer a little quicker there. Here, now I got x is 2, and we're going to the 4th power. So this becomes 2 to the 4th power, which is 2 times 2 times 2 times 2, which is 4 times 4, which is 16. Over here, we got to do both values here. You're going to have 5 squared plus 2 to the 3rd power. 5 squared, you got to do the exponents first. That's going to give you 25 plus 2 times 2 times 2 is going to give you 8, which is going to give you a total of 33. That's your final answer there. Here we got to plug in 2 for x. We get negative 2 times 2 to the 2nd power. 2 times 2 is 4, times negative 2 is going to give me negative 8 for my final answer there.